Hello everyone, in this video we're going to take a look at several different options for powering your projects using USB-C Power Delivery. I took a look into this in a bit more detail recently when I was building my TS100 Flex-C-Friend, which is a way of powering your soldering iron using a USB-C Power Delivery charger. Before we take a look at all the different modules, I just want to quickly cover what USB-C Power Delivery is, and if you already know this, there'll be timestamps in the description where you can jump ahead. So Power Delivery, or PD, is a standard for USB-C related to delivering power. And if you have a charger that has PD, it'll normally be marked on it, and it will always be using the Type-C port, never the USB-A port. So it is capable of providing up to 100 watts, but most of the supplies don't do that. So this is a 100 watt capable power supply, so they do exist, but they're relatively rare. This one is a 30 watt, this is the 100 watt one, and this power bank is a 60 watt one. The supplies are capable of providing different voltage levels, but that varies from supply to supply. So this one, for example, does 5 volts, 9 volts, 15 volts, and 20 volts, which is almost all of the ones available to USB-C. The only one is missing is 12 volts, and both of these do that. And then I have a smaller 18 watt one that just does 5, 9, and 12. So you'll have to take a look on the charger itself. Usually it's listed on the listing of the page to see what voltages it does. And you'll also notice that you can see what amps it does at that different voltage too. What's clever about USB-C Power Delivery is the device that you're plugging in, which is also called the sink, is able to negotiate with the power supply to decide what voltage that it wants to take. So you can see this one here is cycling between the different voltage levels provided by the power supply it's plugged into, and you'll see it's going from 12 to 15 to 20. So that's normally done as part of a capability negotiation. So if you have a need for 20 volts, maybe your device will say, I need to have 20 volts or else I'm not interested. So then a supply that's not able to do 20 volts, such as this 18 watt one, just won't work. On top of voltage, it's also able to consider current limitations when negotiating too. So the power supply advertises what current it's capable of doing at the different voltage levels, and the sink decides if that is enough for it to be able to use that voltage. I'll talk about that in a little bit more detail with the TS100 later. So first up, let's take a look at these little adapters that actually have the logic for doing the USB-C power delivery negotiation. So this cable is plugged into a power bank that supports all the different voltage levels, and as you can see, when I plug it in, it'll first take 5 volts, but then it will negotiate 20 volts. So you can get these in different flavors as well, that this one takes 20 volts, but you can get 15 volt ones and 12 volt ones. And you can also get them in a male version, so that's a female, where you would plug your cable into that, but this one would plug straight into the charger. So the positives about something like this is they're really cheap, they're small, and they're quite tidy. You can't really get any simpler for your project. The negatives would be that they are not flexible in terms of the voltages that you can use with them. So you can only get 20 volts from this one, and if your supply doesn't support 20 volts, it will just default back to 5. From a TS100 point of view, you could plug this directly into your TS100 and this into your power supply, and it would work, it would power it fine. The problem is that this cable isn't as flexible as the one that you can get with the XT60 connector, and also this one is made using something heat resistant. I think it's silicone, but I don't know for sure, while your soldering iron would melt through this. Next, we'll take a look at designs based on the IP2721, which is what I actually ended up using for the Flex-C-Friend. So these two are modules you can buy from AliExpress, and they're both quite cheap. So this one you can see is really simple. It just has the IP2721 on it and a couple of passives, and this one will negotiate 20 volts, but you can also buy it in a couple of different variants as well. The IP2721 can be configured to support different voltage levels. You can see on this one and also on the Flex-C-Friend there's a switch, and that's toggling a select pin. So there's a select pin on the IP2721 that can change between 20 volts, 15 volts and 5 volts based on the switch. This switch switches between 20 volts and 15 volts, and the same on the Flex-C-Friend. There is a different variant called the IP2721 Max 12 that the select pin toggles between 12 volts, 9 volts and 5 volts. This module here has some ESD protection, which this one does not, and it's generally recommended for power delivery designs that you have some. So if you're buying one, you should probably buy this one. Another difference between these two is this has an LED to indicate what voltage it has negotiated, and I think it's doing that using this IC here, which is unmarked, but I don't know what else that would be doing, so I presume that's it. So the positives for something like this is you don't have to program it, so you can configure it using just your schematic, and it's really inexpensive. The negatives are that you'll find it hard to find stock of the actual IC. I cannot buy it myself at all at the moment. I'm buying them from maker fabs, even the ones that I assemble, not the ones they assemble. I'm buying the actual IC from them. Other negatives is the datasheet is not in English, although you can get the datasheet on LCSC in English, so that's not too big of a deal. Another negative is it doesn't support current negotiation at all, so it'll only take the voltage that you've configured for it or whatever it'll fall back to. Another thing to mention is the IP2721 datasheet recommends switching this before you plug it into the device. So it does work that you can change it based on or when it's already plugged in. So you can see it's doing 20 volts, but you'll see it resets and makes a new negotiation based on it. So yeah, it does work, but I'm not 100% sure why they would say that if it's not true. So maybe it's not meant to be changed on the fly like this, but yeah, as mentioned, it does work. Next up, we'll take a look at the FUSB 302, which is this small square IC here. This requires an external microcontroller to work with it, so this is an ST one here. Great Scott took a look at the FUSB 302 in a recent video, and I'll link to that up above here, but I'm just going to take a look at this module here. So I don't really like this module, and I'll explain why now. So I'll plug it in, and it'll start at 5 volts, and this particular mode just cycles through the different voltages. So as you can see, it can support all the different voltages. But the reason I don't like this particular module is because I don't know what it's going to negotiate when I plug it in. So you can configure what it does negotiate by holding down the power button when you plug it in, and this rainbow effect happens, and then you press this button to change it to whatever one you want. So I think this light blue here is 15 volts, so if I hold down the button and plug it out and plug it back in, it should negotiate 15 volts, and it does. But the problem is that when I pick this up out of the drawer or whatever, or if I accidentally reprogram it to be something else, then I don't like that. You know, I want to be really confident when I plug it in, the voltage it outputs is going to be what I expect it to be. So yeah, I'm not 100% sure. Maybe that won't be a problem for you, but I would prefer if it didn't act like this. Now the FUSB 302 could be used with any other microcontroller and could be configured however you want. It doesn't have to work the way this one does. So it is a potentially good one to use for your project. But as I mentioned in that Great Scott video, he looked at it in a bit more detail, and the code needed to control it seemed quite complicated. So I'm not sure if it's the simplest one to use for your project, but it is cheap, and yeah, it supports basically whatever you want to do with it. Another interesting thing about these modules though is it breaks out the pins for programming that ST microcontroller, and some people on my Discord have started to reverse engineer it, and I think if we could get something up and running on this where you could configure the profiles that you wanted to use. I'll talk a little bit more about profiles in an upcoming module here. But if you could configure it to do whatever you want, so it's based on the project, I think that would be really nice because these are inexpensive. And if you could configure it to be, you know, an exact match for your project, it would be really cool. And you could maybe even just take the button out of it or make the button enable or disable the output rather than it changing the voltage based on when it's plugged in. So yeah, maybe this works out well for you. I just don't like the idea of plugging it in and the voltage being something I didn't expect. I just also wanted to mention that there's a couple of modules based on the FUSB 302 on Tindy. These two from Reclaimer Labs, they're the ones that Great Scott mentioned in his video, and Reclaimer Labs has provided some code that you can use the FUSB 302 with Arduino, so worth checking those out. And then these two that I'm less familiar with that seem to be based using a PIC as the microcontroller to control it. But yeah, check them out if you're interested in more FUSB 302 options. Next up is the ST USB 4500, and this is a reference module from ST. The ST USB 4500 can be programmed using I2C to have different profiles on it, but doesn't require an external microcontroller. So what I mean by profiles are they're basically settings to what voltages it should negotiate. You can configure two profiles to negotiate what voltage you want. So you could say if the power supply is able to do 20 volts at 2 amps, take the 20 volts one. And if it can't do that, if it can do 15 volts at 3 amps, take that instead. So there's a priority given to the profiles based on how you configure them. There is a third profile, but it is locked to 5 volts. You can't configure the voltage on it. So the ST USB 4500 is really nice and configurable. The positives of it are that you can get exactly what you want from it, and if you plug in a device into a charger that can't provide enough current, it just won't negotiate that 20 volts. So that is a good thing for the TS100, because the TS100 has kind of a fixed resistance in the tip of the iron. So kind of counterintuitively, the higher the voltage, the higher the current requirement too. So at 20 volts, it requires 2.4 amps, but then at 15 volts, it only requires 1.8. So if you have a charger that can do 20 volts, but can't do that 2.4 amps, it would be perfectly acceptable to drop down to the 15 volts if it can meet that requirement. Now your TS100 will work slower, but it will work. The negatives are that you need to program it. So if you were doing an assembly of these, that would be an extra cost. It is more expensive than the IP2721. It's almost 4 times the price for the IC, and it has a slightly bigger BOM. The other thing that was a bit of a negative as well is that you don't have very granular control over the current requirement step. There is a lookup table that you can use that's changed in 0.5 amp increments. So you can't make a requirement for 2.4 amps. You would need to make it 2.5 amps. Now there is one Flex-C configuration that you can use on one of your profiles. So you could configure that to be 2.4 amps, but then you wouldn't be able to configure the 15 volts one for 1.8. You'd have to go straight to 2 amps. So that mightn't be a big problem for you, or maybe it is. I'm not 100% sure how big of a deal that will be, but yeah, that was definitely one of the negatives. Another negative I had was I originally read that it has 3 profiles that you can configure, and there's 3 power delivery voltage levels that work well with the TS100, 20, 15, and 12. but you can't really have 3 of them. You can only have 2 because one is locked to 5 volts, as I mentioned. Just taking a look at Tindy again to see what's available for the ST USB 4500. There's 2 different designs, and these are both cheaper than the ST breakout board or reference board that I was showing earlier. I've actually purchased both of these, but quite recently, so they haven't come yet. So the first one is this one by Ketsim, who is actually a user on my Discord, and he has a lot of cool power delivery projects in the pipeline, so definitely check him out. And then this one is by Oxplot, and it's actually really weird or interesting. It's programmed using a light sensor, so you configure it using this web page and hold up the board to the page and program it. So I'm really looking forward to seeing how that works out. He has a video demonstrating it working, so it does work, but interesting. For programming the module, even the ST reference design, I used some code from Oxplot. He previously had a different design that didn't have the light sensor that you flashed over I2C, and I used his code, and I'll link to that in the description below. There's pads on the bottom of the reference board that breaks out I2C pins. So just kind of a last minute update to this. I wanted to shoot some footage of using different power supplies to demonstrate how it would, use the correct profiles based on the power supply's capabilities. So I went to shoot the footage for it negotiating 20 volts, and I plugged it into a power supply that is easily capable of doing the 2.4 amps or whatever, and it only negotiated 15. So I was wondering maybe if I had reprogrammed it since my stream or something. I hadn't remembered doing it, but I reprogrammed it again, and yeah, it's still only doing 15 volts, even though the supply is a 100 watt PD power supply, so it's easily capable of doing the 20 volts. And I've tried it with a couple of other ones as well, and it's the same thing, even ones that worked for me on the stream. So something has gone wrong here, and I don't know what it is, but yeah, I just thought I'd let you know that. The last one I want to look at is probably the one I've spent the least amount of time with, and that's the Cypress CY4533. This is another reference design. So if I plug it in here, you'll see it will negotiate 20 volts, and similar to the IP2721, it does not need to be configured using software. You can control it using just hardware. But different to the IP2721 is that you can also configure the current limit as well. The voltage and the current are both set using voltage dividers, and yeah, there's one for voltage and one for the current. So this blue switch here is configured for the voltage, so it's on 5 at the moment and it got 20 volts. So if I change that to 4, it'll get 15 and so on. On this module here, the current is fixed. The voltage dividing resistors for the current are here, but yeah, there's no way of changing them. This is actually one of my problems with this module for the TS100, that if you go for a fixed configuration for the current like this, the current limit is shared amongst the different voltage ranges. So it would be a benefit for the TS100 to have a limit of 2.4 amps for the 20 volt range. But if that was also shared by the 15 volt range, as I mentioned earlier, the 15 volt range only needs 1.8 amps, that would be a problem. So your design would probably need to incorporate switching both of them. So that would be what, I can never remember the name of these, double throw switch, is it? Or, where you flick it once, but it changes 2 things. And that would increase the BOM pretty significantly because they're not that standard. And you also have this chip, which is quite expensive anyways. So like it's similar in cost to the ST USB 4500. So for the TS100, I think the ST USB 4500 would be a better chip if you were going for the slightly more expensive ones. So that's why I didn't spend too much time on this one. It does have I2C pins broken out, and I'm not sure what they're for. So yeah, there's more to look at with this chip. As I said, this is the one I've spent the least amount of time with, but yeah, I just said I'd let you know what I've done with it so far. Hopefully you found this video useful. If you have any questions or if you have any other suggestions for ICs that we should be looking at, please let me know in the comments below or else on my Discord channel. I want to give a huge thanks to my GitHub sponsors for helping support the channel. Videos like this one are only made possible with their help. I had to buy a lot of different modules to do the testing with this and a lot of different power supplies too, so thank you so much. And that's it. Thanks for watching until the end of the video. I'll see you next time. Bye bye. Tell them to like and subscribe.
No.